Okay, continuing with 4.3. So similar directions to the problems that we just went over on the second part of 4.3, but now we'll want to determine if the lines are parallel or perpendicular. So we still need to find the slopes of each of the lines. So for line A on number 9, here's the 2 points that I'm going to use. Figure out the rise and the run. So the slope of line A, you go down 1, 2, 3, 4, and then right 2. So negative 4 over 2, that's negative 2. And then repeat the process for slope of line B. Okay, here's line B. You go up 2, right 2, using these 2 points on the line. You just have to keep track of what points you're using. Slope is 1. Okay, for A and B, if I'm comparing those, they are definitely not the same slope, so they can't be parallel. I think that should have been kind of obvious on the graph because they intersect. They're not opposite reciprocals of each other either, so they can't be perpendicular. But let's figure out the slope of line C. Okay, here's the 2 points that I'm going to use on line C. The slope is down 2, right 1. So negative 2 or negative 2 over 1. Slope of line A is negative 2. The slope of line C is negative 2. So then those two lines would be parallel. Okay, none of the lines in this diagram are perpendicular, but just A and C. A is parallel to C. For examples, 11 and 12, similar to the previous page that we just went over, or part 2. So we need to find the slope of each of the lines. So line A. To find the slope, use the formula for slope, y sub 2 minus y sub 1, or x sub 2 minus x sub 1. So 1 minus 4 in the numerator, that's negative 3, over 1 minus negative 2, that's the same as 1 plus 2, not 1 plus 3, which is 3. So the slope is negative 1. And then repeat the process for line B and line C. For line B, 4 minus 1 is in the numerator, that's 3. 4 minus 2 in the denominator, that's 2, so 3 halves. These are not the same, nor are they opposite reciprocal, so they're not parallel or perpendicular. But let's figure out the slope of line C. 4 minus negative 2 in the numerator, it's the same as 4 plus 2, or 6. Negative 1 minus 1 in the denominator, that's negative 2, so negative 3. Negative 3 is not the same as negative 1. It's not the opposite reciprocal of negative 3 halves, so none of the lines are parallel or perpendicular. Okay. And then lastly, on number 13, actually I'm going to go over number 14. Both of these lines are in slope-intercept form. This one is not. So for line A, 5y minus 2x equals 1. I need to put it in the slope-intercept form, which means you need to solve it for y. Add 2x to each side. So 5y equals 2x plus 1 is the correct order since it's y equals mx plus b. And then divide each side by 5. So it's y equals 2 divided by 5. Just leave it as 2/5 x. 1 divided by 5 is 1/5. So all we really want to do is compare slopes. 5 halves and 2/5. Those are reciprocals. They're not opposite reciprocals. So don't think that they're perpendicular. Same thing with 5 halves and 2/5. They're reciprocals, but not opposite reciprocals. 2/5 and 2/5, line C, and this was line A, are parallel. So line C is parallel to line A. And that's it. No perpendicular lines here.